A warm welcome to everyone. In today's video lecture series, I am here to discuss on the topic friction circle method, which is a most important classical method used in slope stability analysis. Although it is a graphical approach, this method plays a crucial role in understanding how forces act along a circular slip and how equilibrium is maintained in slopes. So before going into the friction circle method, let us recall that slope stability analysis mainly involves determining the driving forces that causes sliding and resisting forces that oppose it. These forces generate moments about the center of slip surface, and the stability of the slope depends on the balance between these moments. So moving to the friction circle method, the friction circle method provides a graphical way of analyzing circular slip surfaces. In this lecture, we will discuss the principle of friction circle method, its assumptions, graphical construction, determination of factor of safety, step-by-step procedure, advantages, limitations, and applications. This method helps us clearly visualize force directions in slope stability problems. The main objective of this method is to analyze slope stability by resolving forces along a circular slip surface using graphical construction principles. Though this method is very complex, we aim to determine the factor of safety in a simple and conceptual manner. So we are applying empathize stages of design thinking to the above concept. So we are analyzing why to study friction circle method. The slopes in homogeneous soil often fail along circular arcs. In such cases, accurately identifying the direction of resultant forces is very important. The friction circle method helps us understand how shear strength parameters like cohesion and angle of internal friction influences the slope stability. It also simplifies the analysis by providing a clear geometric interpretation of force directions. According to Coulomb's theory of shear strength, the shear resistance at any point on the slip surface is given by plus tau equals C plus sigma tan phi. At every point along the slip surface, the resultant reaction force makes an angle of phi with the normal surface. When these resultant directions are plotted for all points, they become tangent to a smaller circle known as friction circle. Next is graphical representation, that is ideation method of design thinking. In order to construct the friction circle, we first draw the circular slip surface with center O and radius R, then a smaller circle with the same center and radius equal to R cos phi is drawn. The smaller circle is called friction circle. For any point on the slip surface, a tangent drawn to the friction circle gives the direction of the resultant force at that particular point. This graphical approach makes force direction identification simple and intuitive. Next is determination of factor of safety. The factor of safety is defined as the ratio of resisting moment to the driving moment. The driving moment is mainly due to weight of soil mass above the slip surface, while the resisting moment is due to shear strength along the slip surface. The friction circle helps us accurately locate the line of action of resultant force for moment calculations. So the step-by-step procedure involved in friction circle method are: In practice, the sliding soil mass is divided into vertical slices. The weight of each slice and its lever arm are determined. The forces on each slice are resolved using frictional circle direction. Finally, the total driving and resisting moments are calculated about the center of the slip circle to obtain the factor of safety. Next, the advantages and limitations of this method are advantages. The friction circle method offers a simple graphical representation of forces and it is very useful for understanding the basic concepts. However, it is mainly applicable to homogeneous slopes and circular failure surfaces only. The accuracy of the method depends heavily on drawing precision and it neglects detailed interslice force calculations. The applications of this method are it is most commonly used in preliminary slope stability analysis. It also useful in understanding the basics of advanced limit equilibrium methods such as Bishop's and Janbu's method. So this is the mind map representing the friction circle method based on design thinking concepts. Next is assessment. Question 1. The radius of friction circle is given by answer is r cos phi. Question 2. In friction circle method, the resultant reaction is inclined to inclined at an angle of phi to the normal surface. The references for the above topic are listed below. So this is how we have applied 5 stages of design thinking for the above PPT. So thank you for listening to this video. Let's meet again in another video of this video lecture series.